The European Chemical Society recently published a periodic table with a traffic light system denoting how at risk certain elements were of short supply. And of the 92 naturally occurring elements, less than half, only 44, were actually rated as green. Many of these elements are actually used in modern technologies. For instance, if you have a smartphone in your pocket, you are actually holding perhaps 25 to 30 elements, and as many as 20 of those might actually be at risk of short supply. In the Birmingham Centre for Strategic Elements and Critical Materials, we're taking a four-pronged approach to try and address issues of materials criticality. One is regulation, one is reduction of the materials through more efficient design. The more chemical ones are, of course, trying to replace the materials, and very, very important as we go forward in the future, of course, will be recycling. A good example of one of our projects is the ReLib project, which is dedicated towards setting up a UK lithium-ion battery recycling industry. At the moment, there are actually no facilities in the UK for recycling lithium-ion batteries, so that not only potentially causes an issue of waste and safe decommissioning of the vehicle batteries, but it also gives a big opportunity to recover these elements and actually start up a manufacturing facility in the UK.
With the drive for new all-electric cars, there's an important need for high-power lithium-ion batteries. And in terms of these batteries, our research is targeted in improving all the materials in these batteries in order to give them higher energy density and make them safer. The lithium-ion batteries work by reversibly shuttling lithiums. So in charging the battery, we would take lithiums out of the cathode and insert it into our anode. And then as we discharge the battery, we would move the lithiums back. One of the issues though is if you try to remove too much lithium, you can get structure collapse, and this leads to a significant decrease in the performance of your battery. So one of the things we're trying to do is prepare more stable structures so we can remove and reintercalate more lithium and hence get higher power.